Hello, we are group 15 from Linda Grapple's 1 o'clock physics class. The prompt of our project is to take two phone books and intertwine them so that they can carry a card. Instead of using those materials, we'll be using different layers of sticky notes and intertwining them so that they can carry paper clips. The layers of sticky notes we're using are 2, 4, 6, 8, 10, and 12. For the last few trials, we actually ran out of paper clips, so we used the weights from our physics class to measure the weight instead. The concepts that we'll be using in this project is the strength of friction between the sticky notes in relationship to gravity, the impulse at which the last weight creates, the potential energy, the amount of potential energy that is stored at right before the sticky note falls, in addition to the amount of kinetic energy right before the weights hit the ground. We'll be using energy to look at to measure the velocity, the speed of which the sticky note falls. So we actually video recorded the project, but we lost them while trying to get them onto the computer. So the video that you'll be watching is the very first take, just to see if the project worked. And it's a video of the last trial, the 12 sticky notes with the weights. So I hope you enjoy. The 12 could hold before it fell, and it's about 600 grams.
We decided to do this project because all of our group members found it fascinating at how much weight just friction between the sticky notes could hold. So to find the potential energy of our total mass just before it drops to the ground, we use the potential energy equation, which is equal to mass times gravity times height. And we have all of those variables, they're known, and so we just plug them into our equation, and then that gives us our potential energy. We know that no energy is lost when the mass falls to the ground, so therefore we know that energy is conserved. So the kinetic energy as the mass hits the ground is going to be equal to the potential energy when it's still hanging from the post-it notes. And that's the reason that we can set potential energy and kinetic energy equal to each other.
So we use this equation to find friction because we're using the point right before the mass gets large enough for gravity to overtake friction and make the object fall.
Alright, so to solve for velocity, since we know that the initial velocity is 0, and the acceleration is just the acceleration due to gravity, and the height, or delta x, is the height from the sticky note to the ground, which is 0.6 meters, I believe, we plugged in those values and solved for velocity. Alright, so in order to solve for impulse, we needed to have a time and a force. So the time, we used a velocity equation to solve, and we just recently found what the velocity was, and we know that the change in x is the change in height, so we were able to plug in those values and solve for t. And then we know that the force is just the force due to gravity because there's no other forces acting on the sticky.
So this is a small demonstration of our experiment. We have the sticky notes here. There's 4 blue sticky notes and 4 pink, and they're woven together. So there are 8 sticky notes in total that are creating the friction. I am not holding on to the pink sticky notes. They're just staying there by the friction. We have this clip here that is holding up these paper clips. So for our experiment, we would gradually add on more paper clips to create more mass. And when the when the force of gravity was equal to the force of friction, the Post-its come apart and the pink Post-it notes fell to the floor.